Hello, I am Suat. Today I am going to do an application with Raspberry Pi Pico W, and I'm going to use one gas sensor, one infrared module, and one DC step motor. And let's look at first Raspberry Pi Pico W. As you can see here, this is Raspberry Pi Pico W. It has several ground pins, several GP pins, and one 3.3 voltage out pin, and it has 40 pins. And let's look at the circuits. This is our circuits. As you can see here, this is our Raspberry Pi Pico W, and I use one DC step motor, one gas sensor, one infrared module. As you can see here, there's several resistors and one RGB LED, and I use a card for DC step motor because if I don't use that, it turns much bigger than the other than I am using it right now. Okay, and then let's look at the codes. Let me first. Yes. As you can see, I include two libraries, and one is for infrared module and one is for DC step motor. And after that, I define pins. I define gas sensor pin as 26. I define it to 26 because, as you can see here, it has a DC converter. That means in GP 26, it can read analog values. And after that, I define infrared module as 2 and motor pins for 3, 4, 5, and 6. And I define RGB LEDs pin for 10, 11, and 12. And as you can see here, I define it's 2, 3, 4, 5, and 6. And it is 26. It's not 26 pin, it means it's 31 pin, and we need to write it's, as you can see here, for GP pins. Okay, and then I define step per revolution value for how much value it can turn for step motor, and I define my stepper for from stepper, which comes from this library. And in this section we need to write this here, and then for motor pins. And then I define controllers values. I find these values from this code. As you can see here, I write it like this code. I remote HPP library. When I press 1, I find this value. When I press 2, when I press 3, and I define it like for remote control. And then after that, I define gas value as equals to 0. And I define my pin modes for RGB LED, and I start the circuits and with this. And then I define my stepper, my motor speed as 50. And then I define this, I remove receivers with this, and with this code I get signals from I remute this receiver that comes from this controller. Okay, and then I define gas value, and I read it as analog. And as you can see here, when I get values from with orange cable, I get analog values. And then if my gas value is bigger than 300, I print it to the serial monitor as gas value, and then my motor is turning as clockwise, and after that my RGB LEDs lights up as red, which means my gas value is smaller than 300. I define value for remote control with iReceiver, decoded iData, and decoded raw data. We need decoded raw data for value. And if as I said, I define these values up there, and this is number 1, this is number 1, this is iRemote speed 2 is number 2, and iRemote speed 3 is number 3. And if I press iRemote speed 1 while gas value is smaller than 300, my step motor is turning as clockwise and it lights up blue. If I press 2, it's turning again and it lights up as green. And if I press 3, it's turning again and it lights up as red. And the others, when I press the other buttons, it's doing nothing. And with this section, I printed the serial monitor, and then I resumed the signal for the other buttons. And let's compile at first. It is compiling, as you can see. It's done. And then I'm uploading. After uploading in Raspberry Pi Pico W, I get this error, not connected error. I have a solution for that. After the uploading section, I disconnected this USB, and after connected it again, it's supposed to turning connected. And let's wait for uploading ending. Okay, it's uploaded. And then after I disconnected this and after I connected this, yes, as you can see here, it turns again connected. Okay, let's look at the circuit, how it is working. At first, I wanna try it with Cologne. You can use butane propane LPG for gas sensor, but it's dangerous and I don't want to use it. That's why I use Cologne. When I put it in here, and after 300, it lights up red, and as you can see, my motor is turning. And let's look at the serial monitor. As you can see, this is my values. Okay, and it's still turning. And after that, I put it away for else condition. And let's wait for smaller than 300. Yes, right now, as you can see, it is not turning and it is smaller than 300. And now let's press, at first let's press 1. As you can see, at first let me try for the values. Yes, it's all working. Let's push 1. As you can see, I am pushing 1. As you can see here, it turns and it lights up blue. Let's press it 1 again. As you can see, it is turning. And then let's press 2. It is still turning, and after turning, it lights up red. And press 2 again. As you can see, it is turning. And after press 3, it is turning, and after the turning, it lights up red. And press 3 again. As you can see, it is turning, and it is still turning. And this is my circuit, and let's look at the simulation after that. As you can see, yes, as you can see, the code is exactly the same, but the controller values is different, and I change it manually. And this is our circuit. Okay. And now it is that's yes. Right now the gas value is 700 and it is turning. And after, oh sorry, As you can see right now it's 700 and it is turning. After I take it away from the safe level, it has stopped, and after I press 1 it is turning, and after I press 2 it is turning again and lights up, and after I press 3 it is turning again and it lights up. This is my circuit, as you can see. Let's look at it again. Let's look at it again. This is my circuit. I hope you like it. See you.